Good morning guys and welcome to Mind Your Math and geometric representation of a given polynomial. Simple words, graphing. How to transform the given polynomial into a graph or into a, how to transform it into a graph and what are the details that we can read from that particular graph. We are talking only about linear, quadratic and cubic polynomials. The higher degree polynomials is beyond the scope of your particular class. Now, if you are having any doubts regarding the contents of this video, you can mail me in the mail ID given below in the description box. We already learned about the general representation of a linear polynomial, which is f of x is equal to ax plus b. So, we also learned about how to find the zero of this particular polynomial, which is ax plus b is equal to 0 or x is equal to minus b by a. You know that a linear polynomial has got one zero, a quadratic has two zeros, and a cubic polynomial has three zeros. Okay? If you have a linear polynomial, let us say 2x plus 1, you need to find the zero of this particular polynomial. You will equate it to 0 and find the value of x, which is equal to minus 1 by 2. So, which basically means that if you are substituting this value of x in the given polynomial, the value of the polynomial will become a 0. Now, you have learned in grade 9 that whenever you have a linear polynomial or a linear equation and you are drawing the graph, you get a straight line. So, in the graph sheet, if you are plotting this particular linear equation, you are going to get a straight line like this. You also know that depending upon the linear equation, the graph can be like this, like this, like this, however it is. But at one single point in the graph, you can see that this line will be crossing the x-axis. Now, suppose this is the graph of 2x plus 1. Okay, you can see that this particular point is the value x is equal to minus 1 by 2, which means that when the graph cuts the x-axis, that point will be the zero of the given polynomial, or a given graph will cut the x-axis at the points which will give us the value of the zero of the polynomial. Let us take two examples of linear polynomial, figure out the zeros and see whether the graph is touching at that point in the x-axis. F of x is equal to 5x plus 10. Find the zero algebraically and geometrically, and what do you observe? So, algebraically, in order to find it, we will equate the given polynomial to a 0 and find the corresponding value of x as minus 2. After that, we plot the graph of this particular polynomial 5x plus 10. So, first I have put x is equal to 0. So, you will get f of x is equal to 10. Then x is equal to minus 1, f of x is equal to 5. So, it's a rough graph. You can properly plot it in the graph sheet and you can verify. So, when you are plotting this graph and you are drawing the line you are extending it, one thing, whenever you are drawing a line in any of the graphs representing any of the polynomial or the equation, please ensure that you extend it long enough in order to cross the y-axis as well as the x-axis. That is mandatory. See, when you go to grade 12 and you learn linear programming, you have to deal with a lot of linear polynomials or linear equations and draw the graphs. Each and every one of the case, please make sure that the graph is extended long enough so that it touches the x-axis and the y-axis. Okay, so this particular graph, when I am extending, you can see that it is crossing the x-axis at the point minus 2. This is exactly the same value that we got when we solved for the zero of the polynomial. So, algebraically and graphically, we are getting the same value for the zero of f of x. What do you mean by f of x is, what do you mean by x is equal to minus 2 over here? At this point, the graph is entirely on the x-axis, which means that graph has become 0. 5x plus 10 has become 0 for the value x is equal to minus 2. So, in order to find the zero of a linear polynomial, by graphically, you draw the graph and find the point where it crosses the x-axis. F of x is equal to 3x. in order to find graphically, I have equated 3x to 0. My value of x is 0. So x is equal to 0 is a 0 of this particular polynomial algebraically. Plot the graph 3x. 1 and 3 and minus 1 and minus 3 are the values that I have taken. So 1 comma 3 will come over here. Minus 1 minus 3 will be somewhere over here. When you are joining, you will get a line which is passing through the origin. So which is the point at which it is crossing the x-axis? It is touching the x-axis at the point x is equal to 0. Okay, so algebraically and graphically, we have gotten the value of 0. Now that you are clear with linear polynomials, let us move on to quadratic polynomials. You know how to represent a quadratic polynomial in the general form, which is ax square plus bx plus c, where a is not equal to 0. Correct? If you are plotting a quadratic equation or a quadratic polynomial graphically, what you are getting is a curve like this. It can be like this or it can be like this. Okay, this particular curve is called as a parabola. So a quadratic equation, when you are trying to represent it graphically, we will end up with a parabola. Now a parabola can be of any form. Look at this parabola. Look at this particular parabola. What can you observe? It is like a U that is open upwards. But is it always necessary that the U should always be upwards? You can also get a parabola as I drew before like this, which is opening downwards. Now, you can say that this parabola is crossing the x-axis at 2 points, but this parabola is not even touching the x-axis at all. I can also have a parabola like this. I can also have a parabola where it is not touching the x-axis. So, depending upon the quadratic equation that is given to us, we can have different kinds of parabolas. Each parabola represents a different solution or a different zero of the given polynomial. Now, let us analyze each of the parabolas one by one. Suppose we have a quadratic equation and I took a graph sheet and I plotted it by giving different values for x and finding out the corresponding values for y, and this is what I have got. You can see that this parabola starts from somewhere here. It is, you can put any number of values, it will go down. Now I have drawn only till here. So it starts from here, goes up, reaches a point over here and then comes down. And you can see that in that particular process, the parabola has crossed 2 points on the x-axis. What did I tell you? I told you that whenever a parabola or a graph crosses the x-axis, that particular point will give you the zero of that particular polynomial. So in this case, 2 points, so 2 zeros. Now, how many zeros is a quadratic polynomial supposed to have? A quadratic polynomial should have 2 zeros. So, okay. Now, in this particular case, when the parabola is opening downwards, when the mouth of the parabola is downwards, the value of a will be lesser than 0. I will take an example, I will plot the graph and I will show you. Plotting of parabolas or plotting of the graphs of quadratic and cubic equations is not there for you guys. So, a less than 0 will mean a parabola that has opened downward, which means that if you have a parabola like this, which is crossing the x-axis over here, this point and this point or this value of x will be the zero of that particular parabola. Fine. This parabola is opening upwards, which means in this case, the value of a will be greater than 0. For example, 3x square plus 2x plus 1, the parabola will be like this. But minus 3x square plus 2x plus 1, parabola will be like this. Clear? Suppose somebody gave you a random polynomial and asked you to plot the graph, and when you plot the graph and you need to find the zero, you suddenly see that the parabola is not touching the x-axis at all. Before crossing the x-axis, the parabola has turned and gone upwards. What does this mean? It means that because this parabola is not touching the x-axis, this parabola has no zeros. See, unlike linear polynomial, which definitely has a zero, because linear polynomial, when you are extending, it will definitely cross the x and the y axis at some point. In the case of parabola, sometimes we get polynomials or quadratic polynomials that do not have any zeros. However, even algebraically, when you are trying to solve, you will not get zeros. The final answer will be no zeros. This cannot be factorized. So when you are drawing the graph, this is what you will get. Or sometimes what you will get is like this. See, you cannot get like this because if you are extending, this will cross. Like this you will get. It will not cross the x-axis at all. In such cases, you can straight away say that that particular polynomial has no zeros at all. Okay. Suppose two polynomials gave you graphs like this. See. Okay. What is peculiar about this graph? It is touching the x-axis, but it is touching only at one point. What can you infer from this? This particular point is definitely a zero of the given polynomial, right? But is this the only zero? A quadratic polynomial is supposed to have two zeros. Where is the other zero? See, suppose you have a polynomial of this form. You need to find the zero. So, it is x minus 2 the whole square is equal to 0, or you can say that x is equal to 2. But you also know that x minus 2 the whole square is actually x minus 2 into x minus 2, which means that x minus 2 is equal to 0 and this x minus 2 is equal to 0. This will give me x is equal to 2 and this also will give me x is equal to 2. So, I have got two zeros, but both the zeros are equal. So, when a parabola is touching the x-axis only at one point, it means that the parabola has two zeros, but both the zeros are equal. When both the zeros are equal, the parabola will touch the x-axis only at one point, but you need to understand that x is equal to 2, 2. Suppose this is touching at 2, x is equal to 2, 2 are the zeros of the polynomial given. It is not x is equal to 2. It is not 1 0. There are two zeros, but both the zeros are equal. Clear? Let us take 2 or 3 examples and deduce all these values from the graph and see how it fits algebraically also. Here I have plotted the graph of f of x is equal to minus x square minus 2x plus 1. Algebraically, you can see that this is x minus 1 into x minus 1 whose 0 is given by x is equal to 1, 1, 2 equal zeros. I have plotted it graphically also. You can see that this graph is touching the x-axis only at one point, which means that because it is a quadratic equation, it should have two zeros, and because it is touching the x-axis at only one point, both the zeros are equal, which is equal to x is equal to 1, 1, which corresponds to whatever we have found algebraically also. Here I have plotted the graph of 3 minus 2x minus x square. I have taken this particular polynomial because the coefficient of x square is negative. It is a minus 1. So I wanted to show how the parabola would look like. I have plotted the points over here and this is how the parabola would look like. Now, one thing you need to take care is that when you are solving it algebraically, what you do is that you take the minus sign outside. Minus sign basically means it is a minus 1 that you are taking outside. So, minus 1 into this particular polynomial is equal to a 0. Minus 1 cannot be a 0. So, either this or both of them can be a 0. That is why you are getting x is equal to minus 3 and x is equal to plus 1. When you are plotting the graph, you need to understand that you are plotting the graph of this polynomial. You are not plotting the graph of this polynomial. Sometimes when students are asked to plot the graph of this particular polynomial, in order to make it simpler, what they do is that they take the minus sign outside, cancel it off and then plot this particular polynomial. This particular polynomial is a different polynomial whose coefficient of x square is a plus 1. The parabola would open upwards. You cannot neglect the minus sign when you are plotting the graph. Plot the graph of the original polynomial in order to get the correct shape. So, this particular parabola opens downwards and these are the two zeros which corresponds with our algebraic zeros also. Okay. So, we have discussed now about the graphing of the linear and the quadratic equations and the significance of the zeros and how to figure out the zeros. In linear equation, you definitely will have a 0. In the case of quadratic, you might have two zeros, distinct ones, or you might have seen a single zero which is actually two equal zeros, or sometimes the quadratic equation has no solution at all, which means there is no zero at all when the parabola is not touching the x-axis. So now we have to learn about cubic polynomials, the zeros, the relationship between the zeros and the coefficients, and the graphing of cubic polynomials.